I'm interested to see research that goes into how to characterize the endocannabinoid system tone more. I think that's really fascinating.
Sure. Well, it's a tough one.
Yeah.
First, let's define some terms.
Yeah.
The endocannabinoid system is the master homeostatic regulator of physiology. What does that mean? Well, physiology is how things work in the body. Generally, you need a certain level of activity, neither too high nor too low. And that's precisely what the endocannabinoid system does, is try and keep things in happy balance. So if a system is overactive, it tends to bring it down. If it's underactive, to bring it up. This works through complex mechanisms. We have endogenous chemicals within called endocannabinoids, specifically 2-arachidonoglycerol, 2-AG for short, and anandamide. Anandamide in particular closely resembles THC. Both are partial agonists at the CB1 receptor, the main psychoactive receptor in the brain and elsewhere throughout the body. And what this does at the brain level is actually reduce the release of neurotransmitters. So if we have a glutamate neuron that's stimulatory, the reduction in the release of glutamate will lower that activity. Good example of why that's important is, well, we'll give two. Glutamate activity tends to be excessive in neuropathic pain, nerve-based pain. So if we have a person with chronic neuropathic pain, we can either raise their anandamide level or supply exogenous THC and bring that glutamate level down. And that's going to help with pain. Similarly, in brain injury, whether it be trauma, stroke, or things of that sort, we get an excessive release of glutamate. It can be so bad, there can be so much glutamate that it produces an excitotoxicity, that the cells actually stimulate themselves to death. We have situations in which people suffer a head injury. They might seem okay briefly and then rapidly deteriorate over 48 hours. And some of that effect is from this excitotoxicity from glutamate. If we're able to supply drugs like cannabidiol or THC early enough, some of that can be prevented and have a much better result clinically. So those would be examples. Going back to endocannabinoid tone. Endocannabinoid tone is an important concept, but we don't have good ways of measuring it.
Right.
The three important aspects are how much of the endocannabinoids are present. Second is, what's the activity of the receptors? If someone is using THC at high doses recreationally, the receptor number will actually go down. It's the brain and body's way of trying to keep things on an even keel. So the receptors become inactive. When they stop, they'll reactivate. So there is the number and status of the receptors. There is the amount of the endocannabinoids. And the third part is, what is the activity of the enzymes that make the endocannabinoids and break them down? So unfortunately, we don't have ways of measuring this directly, except with invasive techniques, such as doing a lumbar puncture or spinal tap to measure anandamide levels. But that's invasive. It's not something you can do on an experimental basis with most ethics committees, for example. Ideally, in the future, we would have scans, non-invasive methods of trying to assess endocannabinoid tone. But that's a dream for the future right now.
Right, yeah. And measuring the endocannabinoids, isn't it a little complicated too, because they're produced on demand? It's not like they're stored in vesicles like a lot of neurotransmitters are.
Yeah, that's exactly right. So these are in a constant state of flux. They're just not there for any period of time. Similarly, they're a very hard thing to study. Anandamide is rapidly broken down in the the bloodstream. So when we are looking at serum levels, which may or may not reflect what's going on in the brain, the samples often have to be frozen in liquid nitrogen and then be transported to a specialty lab. This is not something where you can go into your local hospital and get your blood drawn and see what your status is.
Right.
We're talking some very sophisticated science here.